Hi, Joyce.
So recording this really quickly for Joyce, we just spent time in the back of our spiral working on, we did the first two yesterday and just did the other two today, and our final answers, Joyce, pause it and try them on your own, number 3 and 4. Okay, now you're back. What did you guys get as your final answers?
E.
E, good.
X,
Domain and range.
X cannot equal 0.
And then all real numbers.
All real numbers.
And then even, odd, neither. Limit is,
0.
and then we have our negative 1 over x is squeezing on one side, because cosine is limited by negative 1. 1 over x is squeezing on the other side, and basically if you take the limit of the whole thing, just think about the whole limit. That one's 0, that one's 0, so therefore this one must be 0 as well. That's not a very technical way, but that's the main idea. Okay, we are going to go on to section 2.3 in just a second, but first of all, let's go ahead and get over to the solutions manual. The answer key. You guys had your evens, yeah?
Yeah.
Yeah.
We had a bunch of problems.
Number 6 is the first one.
Alright, Sam, you ready? You're going to be me.
Oh, that's
Come
definitely
find evens tomorrow. All they have to do is grade. Color pens out, right? In your spirals?
Mm-hmm.
We'll go ahead and tape it. That way if Joyce wants to go ahead and go through with this, she can. Color pens out to grade. Sam's going to go ahead and go to the next event. As you guys are there, you can just go up to the board or use the mouse, whichever one's easier for you. Number 6 is the first one. There you go. You guys see it?
Nope. He's not on the right page.
Ooh, that's the one. Alright, when you're ready, let them know the next number to go find.
Number
Number
8?
8.
76, right?
Everybody ready?
Yeah.
Number 8. Wait a minute. Did it ask us for plug it into the function and see what the value is? Is that part of the question?
No.
No?
Wait, what are you saying?
For 8, were we supposed to put in 1 and see what the y value is?
No.
Why did you do that?
It's a horizontal aspect. At y equals 1.
Oh. But it just said to find the two limits. It didn't say don't find more than
Find two limits.
C.
Number 8.
It
And then
says
C
A,
is low.
For number
find
8.
to infinity, B is to negative infinity, C is identify horizontal aspects.
Oh, whoops. I guess I missed that part.
Alright,
Number
16. This one I had trouble on.
Yeah, I got infinity.
Oh, it's
It's negative. That's what I saw, but I wasn't.
Wait,
What?
how?
That's what I was saying.
Because it goes from positive side.
So from
So
the
positive
positive
side,
side.
it goes
More.
it goes this way. So
I just saw
negative.
it without the graph.
I just put in like a
Oh.
little bit more.
How do you solve it? I'll put negative- I'll put negative 4
Oh, it said negative.
Yeah, I didn't
not
see the
positive
negative.
3.
and then negative
That's why.
4.
'Cause that would make
Ah
it
no,
more-
not negative 4. Little bit. It's from the positive side. So
So like negative 2.
yeah, negative 2 would be good. So
I
if it's
definitely didn't see that.
put negative 2, then it
Yeah.
will be negative 1. So it will go downwards. So negative infinity.
You could put negative 2, right? Is that what you just said?
Yeah, negative 2.
So that'd be negative 2 over 1. So it'd be negative 2. So it's going down.
What's next question?
20.
This one
I got infinity. That one just took me a second.
20.
Negative infinity. For the love of God, why?
How do you do
So,
that? That one I
you
answered.
explain that one.
This
Oh.
one?
Yeah.
1 over cosine, right?
Yeah.
Secant 1 over cosine. Then if it's 1 over cosine goes to positive side, right? From the positive side, it goes this way. So if you draw the graph, it will go from negative point something, 0.1, negative 0.2, right? Then if we inverse it, that will be negative 10, negative 20. So it will go to negative. Then it's
How would
infinity.
you do without the graph though?
Without the graph, I don't
Yes.
know. I'll try to draw the cosine graph first.
No, I think like since it's going from the right of pi over 2, so I guess something a little bit bigger than pi over 2, which would be like, let's say, 2 pi
Yeah.
over 3, and that's a negative cosine, so then you know that cosine is going to the negative. I didn't know. Oh, that's what I did wrong. Okay.
30.
That way of solving it.
This is a whole like mess.
A. There's a. Or yeah, there's. Let's see the A first.
Negative 1/2.
Negative 1 and 3.
Okay.
Yes.
B.
Then B is down here.
Negative 1/2 is infinity.
Infinity, negative, infinity.
Right hand is a negative infinity.
Oh.
Remember
Left
coming
hand.
in towards the vertical asymptote, not extending to the ends of the graph.
Is infinity. Right hand is negative infinity.
Was it so they were asking us to find on
So
both
limits.
sides?
Yeah. So limits negative to from the negative
Oh.
side or from the positive side from the
Coming in.
negative side for the positive side.
On the right it goes to negative infinity. On the left it goes to infinity. I wrote 0 for some reason. Left infinity, right negative infinity for the second part.
Second.
Okay, good. Got it right.
Okay, so are we good with that one?
Mm-hmm.
35 through 38.
36 and 38, I guess.
35 through 38.
Miss D, the match didn't necessarily graph up. Match up.
Yeah, because the way that I did it is that the top wins. Therefore, it goes to infinity on the top and negative infinity on the bottom for 35. Therefore, it should have been one of the other graphs. So I don't know what they're doing.
Okay.
Okay,
It's
hold
end
on.
behavior.
End behavior model is trying to think not necessarily for all the in-between points, but eventually as x approaches infinity and negative infinity, what in essence is the graph going to behave like? So you take basically what we do with the leading, the highest degrees, the term with the highest degree on top and bottom.
Oh,
We
why do you do the bottom?
simplify, huh?
Because
Why do you do the bottom?
It's restricting the top.
Because the top is being restricted or divided by the bottom, so the
Got it.
overall degree is going to be a square. Now, there's going to be some funny stuff, probably like in Zoom standard, like negative 10 to 10, maybe a little bit bigger. But eventually, what ends up happening is the top is brought down a degree by the bottom, and so we can say that it's going to behave as you go towards infinity or negative infinity as 2x squared.
Got it. That makes sense because I was trying to figure it out because the two of the graphs look the same as the other two, but it's because I didn't divide by the bottom.
Oh, there you go. Jordan.
Can I try to go up and explain it?
No, I
It's
got
okay.
it.
I mean,
she,
like-
she explained it, so
I'm good
it'll
now.
be fine.
Okay,
Next question.
Then checking 36 and 30.
Misty, why didn't the graphs look like why did they look all weird? Was it like really zoomed in?
No, there's. I think it's just.
Because like it was like one, it was like not even a. It was like one was like a point something.
What?
No, it doesn't. It doesn't really matter. You could
Like-
find if the end is going to both sides infinity. It will be even, so it will be the first
Yeah, as you
35.
zoom out,
So-
the ends are going to look similar, but as you zoom in, there's going to be probably some differences.
No, because like on the graphs that they had on the page, they were like
It doesn't really matter. It's like not in scale. Think it's not
Okay.
in scale because
not on scale with like our calculator.
yeah,
It
because
really like zooms in.
if they don't indicate it, it's like not in scale. Think it's
kinda
not.
like the
Remember
broad
what they're
term.
giving you too? They're giving you the 2x squared, the 1/2 x cubed. They're not giving you the messy function. They're giving you the end behavior model,
There will
which
be
is going to be simple. But the one you have is going to be a little bit complicated in between, but as you extend, is going to model or follow the simple one to infinity and to negative infinity. Does that make sense, Ryder?
Yeah.
So they're not giving you the graph of actual functions, they're giving you the end behavior ones.
No, I know.
So why are they funny? I mean, they're Zoom standard.
No, they're not. I zoom. I
Let's go to the
graph.
next one.
I graph the end
44.
behavior function
44.
on my calculator and it looked nothing like that.
2x squared is definitely an upwards parabola.
Yeah.
1/2 x squared is, or negative 1/2 or whatever, is definitely a downwards parabola.
They will
Yeah.
choose something. It will be really
But, like-
distinct. Don't care about it.
Fine.
Okay, so
If it's-
Sam,
Okay.
sorry, we're gonna ignore this.
Yeah.
If on 41 and 44 it was saying find a power function and behavior model for f,
Mm.
that is the top over bottom of the biggest
Yeah.
coefficient
How about the
of the. Okay, that makes more sense.
Why do they have a different name?
And then the simple function would be the equals.
Yes.
Okay, I was confused. I didn't know how to do those two.
simple
Makes
function.
more sense now.
What's simple function?
The 1/2x is simpler than the original that you had in number 41, which was
So find power and behavior model
x
for f.
minus 2/2x squared plus 3x minus 5. So ultimately, your big, huge one, take the highest degree terms at the top and the bottom, simplify the two. Kind of like we have you do with the horizontal asymptotes. We just have you do it real fast and don't ever connect it with, hey, that function that you get before you take the limit is going to model what the ends look like of the original that's much messier with a binomial on top and a trinomial on the bottom, like the 41. Does that make sense, Brad?
Yeah.
So we say it's simpler to say the end behavior model is take away all the extra stuff as you go to infinity, it doesn't really matter, it becomes negligible.
And then for the B part of it, it's find a
Just
simple.
identifying the asymptote
Got it.
or the limit to infinity and saying bottom line 0,
Okay.
etc., etc.
Simple. Wait, are you talking about 45 or 44?
I'm looking at 41 A and B, sorry.
41.
41.
41 and 44. Same
Doesn't say anything about simple.
It says find a simple basic function as a left end behavior model for the function.
That's 45.
And 41.
41 is find a power function and behavior model for f, identifying the horizontal asymptotes.
True, but when they say a simple basic function, we're saying we can kind of generalize and say end behavior models can be kind of described as simpler functions.
Next.
48.
48.
Okay, so you guys got really quiet.
Thinking.
Questioning?
It's just that it's if you take the limit to infinity, it's infinity plus
What?
any.
This one, the top, they separated it. X over x squared over x squared plus sine x over x squared.
And then when you do squeeze theorem for sine
Sine
x
x
over
over
x
x.
squared.
You can say sine x is 1.
I mean, if you just
Do
take
it.
the limit,
Yeah.
like just blatantly, you can just see that.
Yeah, see that sine isn't as strong, so you can just look at the x squared over x squared, so ultimately 1. That's the trick. And then for the actual explanation, we could use squeeze theorem if we needed to, which is what they're showing. Does that make
Do we?
sense?
But do we have to show this?
Well, on the AP,
No.
you're definitely going to use the tricks. You're going to go fast. We're
On
just
the
looking-
multiple choice, yeah,
Yeah.
tricks is okay, but for free response, don't do it.
Oh, thanks for telling me.
We're not looking at AP tomorrow, bud.
No, I mean thank you for telling me. I didn't know that before.
Oh,
It feels sarcastic.
I'm sorry.
no, you're okay.
Is it too late to drop this class?
Yes.
Okay, you guys good?
No.
What's the next one after 48?
70 is the last one.
Okay, now how did you get that one? I'm sorry.
What?
How did you get the one?
With the squeeze
This one?
theorem,
Yeah.
Or this
sine
one?
x over x
The
squared.
first one or
Yeah.
second one?
The first one.
Because x squared over x squared is 1.
Part method.
I call it Hart method.
Ah.
Last year, yeah.
Take the limit separately. and see what you get.
The problem is with Hart method, it used to be Mrs. Loftus would teach it in pre-algebra a long time ago. But now I just use it and some people don't know what it means because I apologize. Okay, go ahead and say go to number 7.
Oh,
70.
There you go. Let's start at 70.
Yeah.
No, we need back now.
Yeah. I'm sorry.
Can we go over 69, 70, and 71?
Yes, please. Some of the odds.
The first this one is on the log. Log, you could get rid of the scared.
That just makes so much more
They
sense.
bring down the 2, get rid of
Here,
the backs.
they get it.
What were you guys trying to do?
I did that.
I
The,
would
the
think
top
that-
power is greater.
Yeah, I said it was better. It was greater because it's x squared. But that makes so much more
They did a
sense.
change of base formula.
Do you see why I gave you these funny ones at the end?
Yeah.
They're great problems because they're tricky.
So does that mean that you can't say that since the x squared is greater on the top, it's
Remember, it's an ln, so all bets are off. We need to think about ln specifically.
okay?
Does that make sense?
On 70, did they do the change of base formula?
Yeah, totally.
Okay.
Because same thing, ln and log, how do you compare those? We have to get them in the same terms. And the only way to get the same terms is change the base. Hey, good catch, bud.
I have no
I was
idea.
trying to
They did
stump you guys
71
on
though.
71.
71 is like, I have no idea.
71.
What's the answer?
Oh,
Just go on just a tiny
71
bit.
is 1.
I got
One?
0.
I got one, but I
Nice.
no, it's 0.
I was right.
Oh, because the top says 1.
Yeah, I just said because it was gonna end up being equal on the top and on the bottom because x plus 1, the 1 isn't really gonna matter when you put infinity in, right?
Isn't there a what is it called? It's
That makes sense to me, right? You ever see 71 that makes sense? Plug in infinity, the ones that really not going to matter.
isn't there a property, Misty, that
Yeah, that kind of makes sense.
ln of x plus 1 is ln of x times ln of 1?
No. What is the property though? That's the illegal way.
The
That's
proper-
like making up what
Oh,
it's not.
I got it.
There's
The
ln
property
of
X
if you
times
ln
one.
in the ln, if there's multiplication, you
Right.
can do the addition.
separate
If there's
Inside multiplication becomes addition of separate logs, but you can't say log of addition is anything. That's
Oh.
something special.
and then
Wrong.
division is minus.
Yeah, it's a super easy mistake though, Jordan. That's one of like the properties everyone thinks, but it's one you're just making up that's not true.
Okay, what do you do then?
So what they did is they technically just like mathematically show why, because once again, the idea of, I mean, they're both ln's. One is x plus 1. The plus 1 is going to be negligible as x goes to infinity. That's like the trick. I would have guessed 1, 2, for that reason. But and the reason it doesn't work in number 70 is ln and log are two totally different bases. Yes, they're both logarithms, but you can't compare them without changing the base and having ln. Okay. So then what they did is they changed x plus 1 to be x times 1 plus 1 over x.
So they can get rid of
They
this.
they made it into a product so they could separate. Basically, they were trying to get an ln of x. They were trying to get an ln of x because then they could go ahead and do what they did a little bit earlier, where they split it up by Hart method. So you had ln of x over ln of x, which is 1. And then you have an expression 1 over x goes to 0, ln of 1 over ln of x. Of course, ln of x wins, which would be 0. So you can show mathematically why, as opposed to like, oh yeah, it makes sense. But oh yeah, it makes sense. Does that get you a point on the AP? Yeah, it does.
Wait, what? What does that mean?
Meaning, if it's a multiple choice question, and if you just look at it and say, oh yeah, 1, you'll get it just as right as someone who is able to quickly think through all the logic of it. Does that make sense? So the tricks are very valid on multiple choice.
Oh,
Helps you
multiple
go faster.
choice.
Yes.
Can you give us something like that on FRQ?
I haven't seen any FRQs where you've had to literally justify why a limit is what it is. There have been some FRQ parts with limits involved.
But normally
L'Hopital's, there has been.
Not something
FRQs goes with derivatives and
And like,
Derivatives and integrals,
integrals.
and a few little
Application
extra
of them.
pieces. And usually the
like
justify
velocity and acceleration.
applies to theorems or applies to making applications or interpretations of your data. Were there any other odds you guys wanted to see?
The bottom, it's 1 plus 0 over, what is it? What's
What?
the bottom?
no.
It just goes to infinity. So 1 plus 0 over infinity.
No, because it's so I got 1 plus the limit is x approaching infinity of ln of 1 plus 1 over x over ln of x.
So on top,
This one
Damn.
here, it goes to 0.
this
right?
goes to
This-
0. This is a
then
constant over this going to infinity. This bottom wins, so this all goes to 0.
1 over x is infinity. Our limit goes to
But
0.
that whole top
what am I
part,
talking?
that becomes a constant?
Yeah, because 1 over infinity, right, thinking about it, is 0. ln of 1 is 0. So you have 0 over, well, this getting bigger and bigger, but still 0.
I got okay. But why can you split up the limit like that?
No, I'm not, but I'm taking the limit. And so the limit says plug in infinity or think about going to infinity of the x.
Oh, so that just becomes ln
1
of
doesn't change, x changes, which makes that whole thing go to 0, 1 plus 0.
So it's ln of 1 over ln.
And ln of 1 technically is 0, but either way, ln of 1 is a constant no matter what, so it doesn't really make a difference.
Infinity. 0 over.
Notes open!
Thank you.
But those ones are tricky.
Something else. I'm dying over here.
I know.
I've never wanted to take notes in my life.
Aren't you proud of yourself, or did you want me to take
Oh, man.
Misty?
Yeah.
Does that mean that 0 over infinity is 1?
What?
No. 1 plus 0 is 1. 0 over infinity is 0. 1 plus 0 is 1. There's a 1 plus outside that whole expression, but
Oh.
you see it? Alright, section 2.4 is going to be a one there. It's not going to make it super long. It's going to be on continuity. Section 2.3. You guys can start to label.
It's 2.3 or 2.4? Continuity.
2.3. Right? Isn't that right?
Yeah.
2.3 continuity. I want to make sure I don't want to delete any of this.
That one's easy. I love continuity.
Good.
It's easy peasy. Lemon squeezy. It's just lemons. I keep thinking today's August. Only 2016, right?
Yeah.
Okay.
I always forget that.
Time is a concept made up by the government.
Let's go get this. And
Right.
Yes.
Function is continuous if the limit as it's approaching from the negative side is equal to that from the positive side. is
Okay,
equal
so
to
why
the
do these
f-
fail?
Number 3?
Because there's a hole, the limits do not agree.
No, don't say there's a hole. Be precise. But you're right. There is a hole.
FFC doesn't exist.
FFC doesn't exist. I'm just gonna put a little X to say doesn't exist. Over here.
The limits do not agree.
Ah, the one-sided limits don't agree. True, which ultimately means the limit does not.
Exists.
True. So the one-sided limits don't agree, meaning the interpretation application. Third one. You can kind of say two different things, and they're both right.
Vertical.
There is a vertical asymptote, which means technically, since it's infinite, is the limit a constant? Technically, it's non-existent. We would say infinity. But if you don't like that, still, it doesn't matter. FFC does exist, but do they agree?
No.
No. And then the last one, last but not least, the limit does exist. Uh-oh. The one-sided limits agree.
But
FFC does exist. Uh-oh.
they don't agree.
But they don't agree. Does that make sense? Okay. So then you guys don't technically need to rewrite. Woo! I'm gonna die. The next part. However, should this ring some bells? Right? I don't want you guys to write the entire thing because it's in your forever card. However, what part do I want you to write? The one part that Amanda and George have both been referring to, which is the long story short of it, right? And the long story short of it, go.
Limit as x approaches.
From the negative equals from the positive equals FFC. That's the working method.
That's the working one. And specifically the working one for complicated things like piecewise functions and graphs. For normal functions, hopefully we can just look at them and think about their domains, et cetera, et cetera, et cetera. So you don't have to write the entire thing. It's in your forever card. But I do want you, just for the working method, for having in your notes for this section, go ahead and write the box. Go ahead and write the box. If you want to leave space and go back to the graphs, you most definitely can, but the box is the most important. We've been around forever card.
Number
4 or
3.
5.
It's really three.
Yes.
Oh, I did these three.
How do you know that?
This year, I'm not actually doing forever card A and B, so then it's like going to be their forever card 5. That's alright.
Last year we only had appendix A and then we started at 1.
Oh yeah, you're right. It was the year before I did.
The appendix A through up 1.
Okay, so let's do a quick recap. And actually, I need to correct an error I made last year. I didn't figure out until I was actually looking at your textbook, the BC one, that I was a little off. I think I might have still said it right. I definitely said it wrong this year in AP. I had to go back and fix it today. But removable discontinuities, holes, and jumps. What do I mean by that? Each is a normal, you can factor out or do some sort of like creative math, right? Because how to remove, we can do factoring, we can do simplifying, other simplifying like complex fractions, multiplying by a conjugate, trade properties, etc. That's the first one, but the second one, he would be a piecewise function, right? And it's specifically a piecewise function where you have some sort of f of x defined at x equals c. No, it doesn't equal c. And then some sort of constant for x equals c, and they don't match up. And that technically is removable as well, because all you have to do is redefine one point, and then it would be continuous. Non-removable would be breaks, which we already kind of know. Oscillating, they're a break. I can't spell oscillating. Or vertical asymptotes, which would be infinite. So your book has a bit more technical language in the sense of like what these discontinuities are technically called. Their category is non-removable, but their oscillating discontinuities, infinite, which is vertical asymptote discontinuities, and break discontinuities. The break is just the typical, the limit doesn't exist because the piecewise function, what they're approaching from either side doesn't agree. An absolute value is a piecewise function, hence why that one behaves the same. Oscillating would be like our sine of 1 over x, because it doesn't exist, but it's not necessarily a break. It's not necessarily even a whole. It's just its own little dude. And then, of course, we have our vertical asymptote, whether they agree or disagree. So just kind of amending that a little bit from what I showed you guys before. Just amending it a little bit. Oh, what's wrong? There technically is an exploration. We're not going to really take time on it, because number one, we don't have time. Number two, I don't think the results would have been that shocking, but it does put in some new terminology, so it's not a bad idea to peek at that. I don't think homework really has that terminology. I chose wisely, but just to let you know, that is what it is. Now guys, obviously the bell's ringing. I still want us to put these things in notes on Tuesday. So we're going to finish up notes just because there are a few technicalities that I'm like, oh, it's interesting for you guys to know. We're going to do a little bit of AP practice, talk about the IBT, and we're done. Okay, so it's a short section. I totally have full confidence that you can probably tackle the entire homework. We'll do a couple homework questions after we finish notes on Tuesday, but I think you guys should be able to have it ready to go, and that way we can just keep on going to section 2-4 on Tuesday. Good?
Steve?
Yeah.
If the limit equals the if the limit is f of x as x approaches c equals f of c, then the function's continuous.
We have to think about the